Pluto's atmosphere confounds researchers. Observations by NASA's New Horizons spacecraft, combined with new modeling of long-term trends, suggest that Pluto's atmosphere is far more dynamic than anyone imagined. Ever since its discovery in June 1988, Pluto's tenuous atmosphere has been a source of frequent discussion and debate among outer planet specialists. Pluto is so cold, about 45 Kelvin 380 degree Fahrenheit, that the frozen nitrogen, methane, and carbon monoxide on its surface sublimate convert directly to gas, only very slowly. Moreover, given Pluto's strongly eccentric orbit and that it swung closest to the Sun in 1989, many researchers believed that what little gas surrounded this little world would all soon freeze and precipitate onto the surface. In fact, the prospect of a soon-to-be airless Pluto became a compelling reason for NASA to fund and launch New Horizons. Before the spacecraft got there last July, the scientific consensus held that Pluto must be losing nitrogen gas to space at a rapid rate, roughly 1,027 molecules per second. That corresponds to a few thousand tons per day, enough for researchers to question where it's all coming from and whether this dwarf planet has been losing gas throughout solar system history. The New Horizons team had a carefully designed plan for assessing the state of Pluto's atmosphere. First, its PEPSI instrument, a clever acronym that's short for Pluto Energetic Particle Spectrometer Science Investigation, would detect huge bubble of ionized gas created by ultraviolet sunlight and stripped from Pluto's upper atmosphere by the solar wind. Meanwhile, New Horizons briefly would disappear from view behind Pluto as seen from both the Sun and Earth, occultations that would allow scientists to probe the atmosphere from top to bottom. So imagine the team's surprise shock, really to learn that Pluto's upper atmosphere is far colder than expected, roughly 70 K instead of the anticipated 100 K. Consequently, the thin air doesn't puff up high enough to be stripped away by the solar wind. In fact, PEPSI didn't detect any interaction with the solar wind until the spacecraft got to within about 7,000 km of Pluto. Instead, the true escape rate of nitrogen must only 1,023 molecules per second, a mere 10,000th 0.01% of the pre-arrival prediction. There's essentially no nitrogen escaping from the upper atmosphere of Pluto, admits Michael Summers, George Mason University. It's all methane, and very little of that is leaving either. As Summers and the New Horizons investigators detailed this week at the annual Lunar and Planetary Science Conference and in 5 articles published in March 18 THS Science, the reasons for the unexpectedly cold upper atmosphere aren't clear. Perhaps some other compound is radiating away heat to space. Hydrogen cyanide HCN, and acetylene C2H2, are plausible candidates, but observations with the ALMA radio telescope array in Chile last year suggest that there's not nearly enough HCN present to do the job. Meanwhile, the record of New Horizons radio signal as it ducked behind Pluto and then reappeared reveal surface pressures of 11 and 10 microbars, respectively, that is, only 0.001% of sea level pressure on Earth. This meshes pretty well with occultation measurements made last June 29 when Pluto covered a background star as seen from Earth. Hints of a much denser atmosphere. And what about that atmospheric collapse that should be underway? Fuchtabudi. In fact, a series of ground-based occultations suggests instead that Pluto's surface pressure has increased in recent years. The explanation, it seems, is rooted in axial tilt. Its north pole is tipped 120 degrees downward with respect to, up, in solar system coordinates. For much of its 248-year-long orbit around the Sun, Pluto has one pole constantly in sunlight and the other in shadow. Back in 2013, Leslie Young Southwest Research Institute figured out that there's enough frozen nitrogen and methane in the northern hemisphere to keep the atmosphere from completely collapsing. As it turns out, it's not all concentrated at the poles, much of it is stashed the big, icy plain informally called Sputnik Planum. So not only does Pluto's atmosphere never disappear, but under certain circumstances it can also get thousands of times denser than it is now. That's the conclusion of a team of modelers led by Alan Stern, New Horizons principal investigator. They conclude that Pluto's wacky tilt oscillates over million-year timescales, with dramatic implications for how much sunlight the surface receives and how much gas gets liberated. During a press conference earlier this week, Stern explained that even a small uptick in Pluto's surface temperature can yield an exponential increase in the sublimation rate. He believes that, some 900,000 years ago, the air mass enveloping Pluto reached a peak of anywhere from 18 millibars, 3 times the surface pressure on Mars, to 280 millibars, more than 25% of sea level pressure on Earth, depending on the surface's reflectivity and other assumptions. In fact, Stern teased, it's conceivable that the pressure and temperature could rise enough to allow nitrogen to flow across the surface as a liquid. Lake Pluto? Many of the images returned by New Horizons show evidence of glacier-like flows in nitrogen ice-dominated Sputnik Planum. And at least one close-up reveals a small enclosed depression that sure looks like a frozen pond. Another tantalizing bit of evidence involves the string of very dark patches, anchored by a large nicknamed Thulhu Regio, that gird much of Pluto's equator. As Richard Binzel and Alyssa Earle MIT point out, this largely ice-free belt corresponds nicely to the region within 13 degrees of the equator that receives a lot of sunlight but has never been subjected to continuous darkness. Making waves. One other curious aspect about Pluto's atmosphere has come into sharper focus, so to speak. Soon after the flyby, investigators announced that haze layers were suspended in high above the surface. The idea of hazes wasn't new, they'd been implicated for decades as a way to explain works in ground-based occultation data. Besides, once sunlight breaks down methane, the molecular fragments quickly and readily recombine to form heavier compounds like acetylene, ethylene C2H4, and ethane C2H6, and the spacecraft's ultraviolet spectrometer, ALICE, detected all of these. The puzzle was finding so many layers, a score of them each a few kilometers thick and situated at roughly regularly intervals that extend up to 200 km above the surface. 1 or 2 layers. Okay. But 20 of them? Moreover, the ones high up can't, because the temperatures up there are warm enough by Plutonian standards, to vaporize those candidate organic aerosols. An important clue comes from the quasi-regular spacing. As Randy Gladstone and his colleagues explain in one of the science papers, gentle winds that transport heat from warmer to cooler surface regions can trigger the formation of gravity waves while flowing over Pluto's rather substantial mountain ranges. The waves propagate upward, alternately compressing and rarefying haze particles with just the right spacing. Some other process might be involved, but gravity waves offer the best explanation. It's almost like the atmosphere of Pluto is ringing in a radial direction, Summers explains. What other surprises await discovery in the New Horizons data? About half of the flyby's observations have reached Earth, the rest will trickle in over the next 6 months. Surely more surprises lie ahead.